କଥା sir ଏବେ आर चार्जर टा लागि छी देखुछन त एटा फोकस एटा चार्ज लागि छी हैला एटा अछि 80% टिके मार्क करथबे दिटा जोरा बैटरी हो सेटा के अल्टरनेट कर दथबे से ई जो चार्जर टा एटा लगे दोन से ना से खराब अछि ना अपन सेटा अबे चालू छी हां एटा के फुल लगा सेटा बैटरी लो एटा बाहर कर लगे दे एटा नहीं से प्लग टा से प्लग टा लगे एक प्लग टा खुले दे लगे सेटा था ओके स्टार्ट कर ऐसे व्यवस्था पानी छीटी पानी पानी सबरा हां पेज एमटी आस्ट्रो एमटी आस्ट्रो बस ऐसे डायरेक्टली करना
Well, good morning, students. Welcome back to the next session on physics. So, due to some technical glitch, we have delayed. Well, now it has been resolved to my knowledge, and let's begin. So, I hope we have done with motion in the last class. We have completed motion. We have discussed the laws of motion, that is, specifically speaking, Newton's laws of motion. And also we have seen the Newton's third law of motion's application, that is the conservation of linear momentum. Fine. So we have dealt with conservation of linear momentum. So in your examination, questions will be very straightforward, theoretical in nature, nothing much to worry about it. Fine. So you won't be having any kind of numerical problems being asked in your examination. Okay. So we have dealt with this chapter. Now today we will be dealing with a very important topic and also quite interesting, and often questions are asked in any of the examination you face. Fine. So the name of the topic is work, power and energy. Alright, work, power and energy. Actually these three terms are related. You can see that work, power and energy are related. If you have energy, you are able to do work. Now if I measure work per unit time or the rate of doing work, it is nothing but power. Alright, so these three terms are interrelated, but we will be dealing with them individually. Fine, so let us start with work first. This is work. Now how do we define work? Let us see. So this is the body that I am having. It is body A. I am applying some force. So by this time we are clear what is force. We have seen this under Newton's second law of motion. Fine. So this is F. So force when applied to a body. Okay, say the body is at a position Well, the body is at a position, say X. Okay, this body is located at position X. So when F force is applied on this body will get displaced to a position, say Y. Then we say that work is done. Okay. So how can we define work? That when force is applied on a body and the body gets displaced, okay, from one position to another position, we say that work is done. Okay. So let us write down its formal definition. I hope it is clear. Okay. We say that work is said to be done if force is applied on a body and the body gets displaced. Force is applied on a body and the body gets displaced. Okay, then we say that work is done. So this is the basic definition of work. Now we will see that work is basically of three types. So one we have is positive work, then we have zero work, and then we have negative work. So yes, so we have these three types of works. Now let us start with what is positive work. Okay, so dealing with first with positive work. Well, how do we define this positive work? So before coming to this positive work, now let us find out what is the general expression to obtain work. Okay, so this is a body. Now I am applying a force. So say this is the direction of displacement of the body. The body is resting on a plane. The body is resting on a plane. This is the direction of displacement of the body. Okay, and this is nothing but the direction of my applied force. So we have a particular angle theta between force and displacement. Okay, so now if this is the force, there will be two components of the force. Why? Because it is acting at some angle with the horizontal. Okay, so this is the angle made by the force with that of displacement theta. So this particular component of force will be F cos theta. Okay, since it is along the direction of theta, and this is the vertical component of force, and this will be F sin theta. Fine. So it is actually the cos theta. You have to use the term cos theta. The cos component comes into picture where you have theta in contact. Okay, where the theta value or you have the theta given over there, you use the cos term, and if and the opposite component or the other component will have the sin term. Well, you can have its derivation in the chapter called vectors in physics, but it's not required over here. In order to understand, I have said you. Alright, so you don't have to go through vectors, not at all. That is not in your syllabus. Okay, now observe here from this point also. This is the center of the body. Fine, this is the center of the body. So the weight of the body is acting in downward direction. Okay, now what can we say? If the body is at rest, if the body is at rest, that means the net force acting is zero. Yes, so we have seen this in Newton's first law of motion. Net force acting is zero. Okay, so that means what can I say? That the body is under equilibrium. Fine, the body is under equilibrium. Okay, if the body is under equilibrium, net force acting is zero. That means what can I say here? F sin theta is equal to mg. If f sin theta is not equal to mg, what will happen? The body will either move in upward direction or in downward direction. But the body is neither moving in upward nor in downward direction. Okay, so body is resting on the surface. That means f sin theta is equal to mg. But the body is definitely getting displaced in horizontal direction. That means the body is under rectilinear motion. So which component is responsible for making this displacement? It is simply the F cos theta component. So we write down work done is equal to F cos theta into S, or I can write this as work done is Fs cos theta. Simply I have rearranged the terms. Okay, so this is cos theta. If I want to write in vectoral form, okay, if I want to write this in the form of vectors, so how can I write this? This can be written as F vector dot S vector, because dot product, when it is resolved in terms of cos theta. Okay, it is resolved in terms of cos theta. So W is equal to F vector dot S vector. Now if you take dot product of any two vectors, you will always obtain a scalar. Okay, you will always obtain a scalar. So that is why work done is a scalar quantity. Okay, so what is the unit to express work? It is nothing but joule. Okay, it is nothing joule. The SI unit of work is joule. I hope the expression of work is clear to you. Now let us talk about positive work. Yes, so let us discuss about positive work. Now positive work means, say this is a body. Okay, I'm applying some force. Now this body is getting displacement. You can see the direction of applied force and the direction of displacement are same. That means I can say that the body is getting displaced along the direction of applied force. So in this case, I can say that work done is positive. Okay, work done is positive. Now, why do we say that when the direction or when the displacement of the body is along the direction of applied force, we say that work done is positive? Why do we say so? Let us see the expression. Okay, so we know F is equal to F vector dot S vector. This is in vector form. So if I simplify this and expand this term, I'll be writing this as Fs cos theta. Fine, I'll be writing it as Fs cos theta. Good. So if I'm writing it as Fs cos theta, so how can I term this, or how can I write this? I will be writing this as W is equal to Fs. Now look, what is the angle? These two vectors, force is a vector, displacement is a vector. The both are moving in the same direction. So angle between them is 0 degree. So I'll write them as cos 0 degree. Now cos 0 degree value is 1. So W can be written as simply F into S. Fine. W can be written as F into S. Okay. So for theta is equal to 0 degree, cos value is maximum. That means I have obtained maximum work. Okay, that means I can say that work done is positive and maximum when the displacement of the body is along the direction of the applied force. Fine. Okay, it is somebody GK gamer. Sound clear nahi aa raha hai sir. Well, let me check it out. Just a minute. Well, I have called the technician. He will be arriving in a short while from now. So do bear with us kindly. Okay, so kindly bear with us. Okay, so this is W max is F into S. We got it. So this is the maximum work done. Okay, so that is nothing but known as positive work done. If I take example of any positive work done, I am taking an example of a positive work done. Okay, so if I take the example, say this is a box. This is a box. Now a man is standing over here. He is applying some force. The box is getting displaced. Yes, and the displacement is along the direction of applied force. So that means here what can I say? Work done is positive. Okay, work done is positive. Well, so I think this is clear to you. Now let us move on to the next type of work. Yes, now let us discuss about negative work. Negative work. Okay, Now what is negative work? So this is a body. Alright. Now I am applying force in this direction. Now displacement is happening in other direction. That means the displacement of the body is opposite to the direction of applied force. Okay. The displacement of the body is opposite to the direction of applied force. Now let us see. So this kind of work is known as negative work. Now both are vectors, both are in opposite direction. So what is the angle between them? Angle between them is 180 degrees. So if I write down the expression, W is F vector dot S vector, this can be written as Fs cos theta. Okay. So Fs cos 180 degree. Now what is the value of cos 180 degree? It is minus 1. So I will write down as W is equal to minus Fs. So I am obtaining a negative sign here. That is why this is nothing but known as negative work. Okay, this is negative work. So negative work is obtained when the displacement of the body is opposite to the direction of applied force. Okay, the displacement and applied force both are in opposite direction. I hope this is clear to you all. Okay, so let us move on to the next type of work. Yes, so we will be discussing about zero work. Okay, let us discuss about zero work. So I am having a body here. Say its mass is 1000 kg. Huge mass, right? It's a huge mass. So this is my surface. This is surface. So I am having a man standing over here. His mass is 45 kg. Okay, this is not weight. We do not measure weight in a weighing machine. That is the mass that we measure. Okay, so mass and weight are two different terms. Mass is the amount of matter contained in a body, but weight is when you multiply mass with acceleration due to gravity. That is 9.81 meter per second square. You obtain the weight of the body. Okay, this is a 45 kg man, and we have a body of 1000 kg, and this fellow is applying some force on that body. Do you expect this body to move? No, this body will not move. It has a huge mass. Okay, so displacement of the body is 0. So if I write down work as Fs cos theta, so this term, this particular term will become 0. So what will be my work? My work will be 0. So we can say that zero work or no work is happening. Okay, no work is taking place when force is applied on a body and the body does not get displaced. Okay, so this is a kind of zero work, and there is also another kind of zero work. Say this is a body. Okay, I am applying force, say in upward direction. Now displacement of the body is occurring in horizontal direction. Force is applied in upward direction or vertical direction. Displacement is in horizontal direction. Okay, what is the angle between them? 90 degree. So this is my theta. So theta is equal to 90 degree. So work done is equal to, what will be my work done? Fs cos theta. Yes. So W is equal to Fs cos 90 degree. Okay. So cos 90 degree value is 0. So W is 0 again. So that means I can say that when force and displacement are perpendicular to each other, work done is 0. Okay. I take an example of it. If I take an example, you might have seen a porter man. Okay. Or say coolie. Okay. Coolie. So what he does? If he is a coolie, he is carrying a box. Okay. He is carrying a box. So by doing this, he is applying force in upward direction, and his displacement is in horizontal or plane direction. Okay, it is in horizontal direction. So what is the angle between them? 90 degree. So what will be my work done? 0. Okay, my work done will be 0. I hope it is clear to you. Well, so these are the three types of work. So now let us look into the next part. Sound doesn't come. Sound doesn't comment us to sound नहीं ठीक से sound clear नहीं से
साउंड क्लियर नहीं तो देखते हम क्लियर আছে हम কোনটি বাফারিং হতো সাউন্ডটা ঠিক আছে
ठीक है सो
সাউন্ড ঠিক আছে
अच्छा well so this was all about work. So now let us deal with energy. Okay, what is energy? It is the ability to do work. Okay, it is the ability to do work. If you have taken your food or if you have taken your breakfast in the early morning, you might be having some energy, right? So you are able to do some work. But if you do not eat properly, okay, you do not have a healthy diet, then what will happen? You will lack in energy. Fine, you will lack in energy. So if you lack in energy, you won't be able to do work. Alright, your body metabolism won't be able to be carried out, and you faint finally, or you feel extreme tiredness and lethargic. Fine. So energy is nothing but the ability to do work. Now let us understand the energy contained in by a body, or sorry, energy contained in a body. I hope the sound issue has been resolved right now. Alright, I could hear the voice, it's quite clear over here. So do let me know if you face any trouble in the sound quality. Okay, yes, so energy contained in a body. Energy content in a body, let us discuss. Actually, the energy content in a body is known as mechanical energy. It is known as mechanical energy. Okay, now this mechanical energy has two components. One is a potential energy plus kinetic energy. Now mechanical energy is a sum of potential energy and kinetic energy. Now let us understand one by one. But before that, always remember that mechanical energy of a body or a system is always conserved. Okay, mechanical energy of a body. Yes. Music with Mitali. Thank you so much. Okay, fine. It's clear right now. Okay. So conserved, yes, mechanical energy of a system is always conserved. Fine. So this mechanical energy is comprising of potential and kinetic energy. So if it is conserved, that means it is always constant. Okay, it is always constant. Now if it is constant, and say if I say my potential energy is increasing, what will happen to kinetic energy? This has to decrease. Yes, if this will decrease, then only I can say it is constant. Say my total mechanical energy is of 10 joules, out of which my potential energy is 5 joules, kinetic energy is say 5 joules. If I am increasing my potential energy, say by 2 joules, so what will be my new potential energy? It will be 7 joules. Yes, it will be 7 joules. But if I keep my kinetic energy constant and increase my potential energy, what will be my new mechanical energy? It will be 12 joule, which is absolutely wrong. Yes, it is going to be absolutely incorrect. Why? Mechanical energy is always conserved. Yes, so that means the value has to be constant. So if it is increasing by 2 joules, how much this has to decrease? It has to decrease by 2 joules. Okay, minus 2 joules means it has to decrease. All right, fine. So now let us understand what is this potential energy and what is kinetic energy. Okay, now let us start what is potential energy. Okay, let us understand what is potential energy. Let me take an example. This is the surface. Okay, I have a ball over here. This is a ball. Okay, now this ball is at some height. Okay, this ball is at a height of say h. Now potential energy is the energy possessed by this body by virtue of its position. I'll write down the statement. Don't worry. Okay, don't worry. I'm just saying you for your understanding. Now see, this is a body or a ball. It is located at a height h. So when this body is taken to a height h, this body definitely has some energy known as potential energy, and that energy is nothing but by virtue of position of this body. Okay, so potential energy can be defined as energy possessed by a body by virtue of its position, by virtue of its position. Okay, and how do we express potential energy? As mgh. Now what is this m? M is the mass of the body. Okay, m is the mass of the body, and small g is acceleration due to gravity. Now what is this acceleration due to gravity and all? We will study in details in the chapter called gravitation and satellite. Okay, now look over here. So this is my potential energy. So I hope this is clear to you. So what can I say now? M into g is the weight of the body. M into g is the weight of the body. Okay, so I can say potential energy is directly proportional to h. Potential energy is directly proportional to h. That means if I increase my h, my potential energy will also increase, or it can happen vice versa. If I decrease the height, potential energy will also decrease. Okay, so this is, I think, clear to you all what is potential energy. Let us understand the next term of mechanical energy, that is the kinetic energy. Kinetic energy. Now see, what is kinetic energy? So this is a body. Okay, I'm having, this is a body. Now this body is in motion. Now if this body is in motion, definitely it has some velocity. Okay, so if it has some velocity and also in motion, that means this body is having some energy. Now this energy is nothing but kinetic energy. Okay, so this energy is kinetic energy. So how can I define kinetic energy? It is defined as the energy possessed by a body due to its motion. Energy possessed by a body due to its motion. Alright, so I hope it is clear to you. And how do we write kinetic energy? Kinetic energy can be written as half into mv square. Okay, half into mv square. So by this time it is, I think, clear to you all what is called momentum. Yes, we have dealt this momentum where? In Newton's laws of motion. Okay, so I can write this kinetic energy in terms of momentum as well. Kinetic energy can also be written as in terms of momentum. Okay, well, so let me write down this in terms of momentum. This is kinetic energy as half into m v square. Okay, if I multiply m and divide by m, I have multiplied by m and divided by m. So how can I write this? This can be written as kinetic energy as half into m square into v square by m, or can be written as half into mv whole square by m. So I can write kinetic energy as half into p square by m. Okay, so this is the expression of kinetic energy in terms of momentum. So what can I write? Kinetic energy is a function of momentum as well. Yes, kinetic energy is also a function of momentum as well. Okay, I hope it is clear to you all. Okay, so that means I can say mechanical energy is constant or conserved. So if potential energy increases, what will happen to my kinetic energy? It implies kinetic energy will decrease. Okay, so I think this is clear. Okay, now let us understand about law of conservation of energy. Law of conservation of energy. It states that energy can neither be created nor it can be destroyed. It can be converted from one form to another, or transferred from one body to another body. Okay, now see, converted from one form to another and transferred from one body to another, both are two different things. Okay, say if I tell you what is the meaning of transferred from one body to another body. This is a body A and I am having another body B. Say body A is having a temperature of 100 degree, body B is having a temperature of 20 degree. Now that means body Q, or the heat in case of A, is higher than the heat in B. So what will happen? Now the temperature of A is higher than, that will be temperature of A is higher than temperature of B. So what will happen? Now heat will start flowing. Okay, heat will start flowing from A to B. That means nothing but heat is a form of energy. Now that energy is getting transferred from one body to another. This is the meaning of transferred from one body to another. Now converted from one form to another, say this, say I'm having an engine. Okay, in engine what happens? Heat energy gets converted to kinetic energy. Okay, heat energy gets converted to kinetic energy. Now be ready. I'll be naming you some devices. Alright, you have to tell me which energy is getting converted to which form of energy. Okay, well, tell me about candle. Yes, please comment in the comment section below. Okay, so that I can see your live chart. Alright, so do comment your answer. In candle, which form of energy gets converted to which form? Anybody? Yes, I'm waiting for your reply. Please comment. No issue, if it is right or wrong doesn't matter. I just want you to come up with some thoughts of your own. Alright, I'm here, don't worry. I'll be telling you the right answer. I could not see any comment over here. Please, anybody would like to answer? GK Gamer, Arvind Pradhan, Music with Mitali. Anybody? Well, fine. So I think nobody is able to reply. Okay, so let me write down this. So in candle, which energy gets converted to which form? Is in candle, listen. You have, this is my candle. Okay, this is my candle. It is made up of wax. Wax is a form of chemical. So when you light this candle here, when you light the candle, this is the wick of that candle. Okay, so when you light the wick, what happens? The chemical energy will get converted to heat plus light. The chemical energy will get converted to heat plus light. So what is happening in candle? In candle, chemical energy gets converted to heat and light energy. Yes, music with Mitali, you would have replied this bit earlier. I have already mentioned. Okay, no issue. Fine, fine. Okay, yeah. I think the video is running late. Okay, good. Good music with Mitali. So you have replied you have answered me the right answer. Okay, you have replied the right answer. So rest all, please try coming up with some answers. Okay, doesn't matter if it is right or wrong. Well, now let us discuss about the next device, say generator. Generator. Yes, please come up with this answer of generator. Anybody? Yes, Mitali, I understand it's a network issue. Yes, anybody? GK Gamer, Arvind, or music with Mitali? Anybody come up? Well, let me write down the answer. Say in generator, mechanical energy gets converted to electrical energy. Okay. Now see, this is my generator. Now this generator is actually coupled with an engine. Okay, this is an engine. So when I run this engine, this is a shaft. This shaft starts rotating. Okay, this shaft will start to rotate. So what happens? Inside you have magnetic field. So there is a change in the flux. Okay, so due to the change in the flux, you will be having current or electrical energy. Okay, electrical energy. All right. Yes, Itishri is correct. Fine. Subhrarani is also correct. Subhrarani is also correct. Okay, good. You are able to answer the question. So moving to the next, dynamometer. Dynamometer. So dynamometer, which energy is converted to which form of energy? Yes, anybody answer? Yeah, correct. It is mechanical. Subhrarani has answered the right answer. Subhrarani has replied the right answer. Yes, same. It is the mechanical energy getting converted to electrical energy. Okay, so this is the principle of your dynamometer. It operates on this particular energy conversion. Okay, so next device, if I say battery. Battery, anybody? Correct. Yeah, music with Mithali is right. It is chemical energy to electrical energy. Fine. So you have so many devices in this form. So you must know which energy is getting converted to which form of energy. Microphone. All right. Microphone. So in a microphone, your sound energy gets converted to electrical energy. So in speaker, you have electrical energy will get converted to sound energy. Okay, electrical energy will get converted to sound energy. So hope this is clear to you. Okay, say I'm having a body here. Okay, this is my body. Now this body is in motion. This is a question for you to solve, and you have to find the answer and reply me. Okay, in the chat box. This body is under motion. The total mechanical energy of this body is 100 joules. Kinetic energy, the body is also having some kinetic energy. It is 50 joules. You have to tell me at what height is this body is located. Is at what height this body is located. Okay. Assume small g approximately equal to 10 meter per second square. Fine. So you have to answer this question to me. Go ahead and reply this to me. Okay, you can take the mass of the body to be 2 kg. Okay, 2.5. Lakshmi Rani has come up with the answer 2.5. Well, let's see. Let's solve this question. See, we know that mechanical energy is constant. Okay, so conserve mechanical energy is potential energy plus kinetic energy. So you have, so potential energy will be mechanical energy minus kinetic energy. So 100 minus 50, you have 50. Now this 50 can be written as m into g into h. It is asking at what height. So what height means you have to find out h. So h can be written as 50 by 2 into 10. So yes, it is located at a height of say 2.5 meter. Okay, so always try to answer the question in units. Okay, units are especially important. Fine. So Lakshmi Rani has answered 2.5. Magnitude is correct. I just urge you to denote the unit as well. Okay, you should have written a 2.5 meter. That would have been a perfect answer. All right. So let me think that so let me assume that the question is clear to everybody. Okay, it's a simple question. Fine. So let's move to the next part. Well, so let us discuss about power. So what is this power? Power is nothing but what can I write it as? Rate rate of work done means it is nothing but per unit time. Okay, per unit time. So power can be written as work done per unit time. Okay, that is work done per unit time. Now see, what is the SI unit of power? Sorry, what is the SI unit of work first? Joule. This is second. So in between you have division, so joule per second. So this joule per second is nothing but watt, represented by capital W. Okay, so I can say that 1 joule per second is equal to 1 watt. So the SI unit of power is watt. Alright, now see, work done is a scalar divided by time is also a scalar. So this scalar by scalar will give is equal to a scalar. Therefore, power is a scalar quantity. Fine. So hope this is clear to you all. Alright, now let us see. See that we have energy meter. There is something called energy meter. This energy meter is nothing but electric meter, we say commonly. Okay, electric meter, commonly termed as electric meter. Now 1 kilowatt hour, 1 kilowatt hour. So 1 kilowatt means how much? 1000 watts. 1 hour means into 3600 second. So 1 kilowatt hour can be written as 3.6 into 10 to the power 6 joules. Why joules? See, 1 joule per second is equal to 1 watt. Okay, so that means what can I say? Watt into, from here what can I infer? Watt into second is equal to joules. Now that is why this is joules. So in electric meter, we measured energy in terms of 1 kilowatt hour or in terms of kilowatt hour. So this is nothing but denotes what? Consumption of electrical energy. Okay, consumption of electrical energy. Yes. So hope this is clear to you all. So this was all about power, and one more unit. Remember, 1 HP or 1 horsepower. Alright, so this stands for your horsepower is equal to 746 watts. Okay, 1 horsepower is equal to 746 watts. Okay, so hope this is clear to you all. Yeah, so that's it from you all from your, that's it from your watt, power and energy. We'll start with the new chapter, gravitation and satellite. Gravitation and satellite. Okay, so first we will deal with gravitation, and then we'll go to move to satellite. Okay, now see, what is this gravitation? This is a body. Now I have a body here, and this is, yes, let me running doubt thela. Okay, yes, ask what is your doubt. Yes, ask me. See, Lakshmirani, when an object is reached to certain height above the ground, it possesses. See, this is an object I am having here. Okay, it is at the ground. When I am lifting it to certain height, now this body is not having any kind of motion. All right, so better you see here. This is an object I am having here. Okay, this is the surface. Now this object is reached to certain height. Say this is the height h. Okay, this is the height h. Now this body is having simply potential energy. This body is not having any kind of motion. There is no motion. So if no motion, this kinetic energy will be 0. Okay, that means this body is having simply potential energy. So as per your question, option A given. Okay, so option A will be the right answer. Alright, so this is a question not from Newton's laws of motion. This is a question from work or energy itself. Alright, so I hope it is clear to you. So let us start with gravitation. See, I'm having a body. Okay, this is a body whose mass is m1. This is another body, mass m2. So what is happening is that this body of mass m1 is attracting this body towards itself, and this body of mass m2 is also attracting this body towards itself. Okay, so that means, well, Lakshmi Rani, I'll get back to you. Okay, let me complete this concept. So this is a body of mass m1. I'm having a body of mass m2. So m1 is attracting a body of mass m2, and m2 is also attracting this body of mass m1. Okay, that means you take any bodies, any two bodies in the entire universe. You take any two bodies in the entire universe. You will always see that these two bodies are attracting each other. But normally you won't see that this body is moving towards this body or this body is moving towards this body. Why both the bodies do not appear to move? Because this attraction force, this force of attraction, this force of attraction is very weak. Okay, this force of attraction is very weak. Since this force of attraction is very weak, that is why these two bodies normally do not move towards each other. And this force of attraction is known as gravitational force. Okay, this force of attraction is known as gravitational force. Okay, I hope it is clear. Now this gravitational force, so this is gravitational force. This gravitational force is directly proportional to mass of the body. Directly proportional to mass of the body. That means if the mass of this body increases, if mass increases, then gravitational force also increases. Okay, then gravitational force also increases. Fine. So I hope it is clear to you. So question Lakshmi Rani Patra has asked us doubt: when an object is thrown straight upwards, gets to the top of its path, its velocity and acceleration becomes. Yes, see, this is a surface. I am throwing a body. This is the maximum height. Okay, this is the maximum height. At maximum height, the displacement is 0. Why? Because from maximum height, this body is moving in downward direction. Okay, so when the body is moving in downward direction, the displacement of the body is 0. So what can I say? The velocity of the body is 0. Okay, the velocity of the body is 0, but still what is happening? Acceleration is acting in downward direction. So but acceleration is not equal to 0, but velocity will be 0. Okay, so hope this is clear to you. Now let us continue with this gravitation. So till now we have concluded that gravitational force acting on a body is directly proportional to the mass of the body. Okay, yes. So now let us move on to the next part of it. Fine. So let us study about Newton's law of gravitation. Newton's law of gravitation. Now, Newton was the first scientist who defined about gravitation. Okay, so he proposed a law known as the Newton's law of gravitation. So we are having two bodies here. It is having a mass m1. There is another body having mass m2. Okay, so now m1 is attracting m2. m2 is also attracting m1. Alright, now this force of attraction is nothing but known as gravitational force. He stated that, say, this two body, this is the center of body m1 o, this is center of body m2 o dash. Say the distance between these two bodies is R. Okay. So Newton stated that the gravitational force acting between these two bodies is directly proportional to the product of these masses and inversely proportional to the square of the distance between them. Now this is an observational value. Okay, this is an observation value. So that is what he observed, that the gravitational force acting between these two bodies is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. If I want to form an equation, I have to use an is equal to sign and also a constant. Okay, so I can write this as gravitational force is equal to capital G m1 m2 by r square. Okay, now this capital G is nothing but known as universal gravitational constant. Just understand, I will be writing down the formal Newton's law. I'll write down the formal statement of Newton's law of gravitation. So universal gravitational constant. Now this value is fixed. Capital G is 6.67 into 10 to the power minus 11 into Newton meter square per kg square. Okay. So I hope it is clear. Now let me write down the formal definition and the equation properly. Yes. It states that the force, or say it states that the force gravitational force acting between two bodies, the gravitational force acting between two bodies is directly proportional to the product of is directly proportional to the product of masses of the bodies, proportional to the product of the masses of the bodies, and inversely proportional to the square of distance between them. Okay, so that is how we write Fg, or gravitational force, is equal to capital G m1 m2 by r square. Okay, so I think it is clear. So now let us focus on the dimensional formula of G. Okay, dimensional formula of G, capital G. Lakshmirani, is your doubt clear? Lakshmirani, is your doubt clear? If your doubt is cleared, do comment in the chat box. Yes. See, how can I write this? We write gravitational force as capital G m1 m2 by r square. So this implies capital G is Fg into r square by m1 m2. So this G can be written as, what is the SI unit of force? I have already discussed how to find out the dimensional formula, okay, in the lecture, in my first lecture called units and dimensions. Yes, so SI unit of force is Newton, R square is meter square by kg square. Now how can I write this Newton? See, force is mass into acceleration. So kg meter per second square is equal to Newton. So I can write this as kg meter per second square as Newton into meter square into 1 by kg square. Okay. So how can I write this? This kg and kg square will get cancelled. I am left out with 1 kg. So I can write this as m to the power minus 1 L cube t to the power minus 2. So now this is nothing but the dimensional formula of capital G. Okay. So how many of you have got this correct? How many of you have got this correct? If you have got it correct, do comment in the chat box below. If you have got this correct, do comment in the chat box below. Vishwal Nakar sir, GK class when start. I don't have any idea about any other subjects. You can check your schedule or contact whomsoever has been assigned to you. I don't have any idea about other classes. Yes, do comment how many of you got this correct. Yes, music with Mitali, got it. Okay. Now let us understand what is this acceleration due to gravity. Now this is denoted by small g, okay. Acceleration due to gravity is denoted by small g. So this is an object. Its mass is huge, say 1 lakh. Say its mass is 1 lakh kg. I have another small object. Mass is 1 kg. Now this body is having a higher mass, okay. So what it will do, it will attract this small body, okay. So this is my m1, this is my m2. So it is attracting m2 towards itself. Now this body, when it is moving, say this is my earth, okay, and this is, say, a ball. I have taken the hypothetical values, these are not real values, okay. So when you throw a ball from the surface of the earth, what happens? It retracts back again. Yes, it retracts back again. So when it retracts back to the surface of the earth, it has some acceleration or not? Definitely yes, it has some acceleration. So when it is having some acceleration, now why is that acceleration occurring? This acceleration is caused due to gravity force, okay, due to gravitational force. Now this acceleration is nothing but known as acceleration due to gravity. Why? Because this acceleration has been caused because of gravitational force, okay. So that is why this is known as acceleration due to gravity and denoted by small g, okay. Yes. I think this is clear. Now let us discuss about properties of gravitational force. Properties of gravitational force. So gravitational force has generally two properties. So first is it is always attractive in nature. It is always attractive in nature. That means if I am having two bodies, say M1 and M2, M1 will always attract M2, M2 will always attract M1. They will never repel each other. Okay, never repel each other. Do remember, they will never repel each other. No, they will never repel each other. Okay, fine. Yes, so if you have a magnetic force, say if I am having, this is a body, north, this is another body having north. So what will happen? They will repel each other. If I am having north and south, they will attract each other. Yes. So but in case of gravitational force, it is not so. They will always attract each other. Okay. They will always attract each other, or it is always attractive in nature. Second, second is it is the weakest force. It is the weakest force in the universe. It is the weakest force in the universe. Okay. So strongest force in the universe is, yes, anybody? Strongest force in the universe? I'm waiting for your answer. Anybody who can tell me what is the strongest force in the universe? Yes, right. Music with Mithali. It is the nuclear force. Correct. Okay. It is the nuclear force. Nuclear force is also known as strong force. No, Lakshmi Rani, I have written that it is already the weakest force. Okay. My question was which is the strongest force. Okay. Gravitational force is the weakest force. Music with Mithali is correct. Okay. It is the nuclear force, or nuclear force is otherwise known as strong force. Alright. Well, now this small g is known as acceleration due to gravity. We all know. Now there are some factors that affects acceleration due to gravity. Alright. So the first factor is the height at which the object is located. Height at which the object is located. Second, the depth at which object is located. Third, shape or radius of the earth. Shape or radius of the earth. Fourth is rotation of the earth. Fourth is rotation of the earth. So these are the four factors that influences the value of small g. Okay. Now let us discuss one by one factor. First, let us discuss about this height. Any doubt anybody is having? Do comment me in the chat box. If no doubt, please anybody of you write down no. Any doubt? Lakshmi Rani Patra or Music with Mitali, Subhrarani, JK Gamer, Vishwal Anakar. Any doubt? Anybody? If you do not have any doubt, please comment no in the chat box. Then I'll be proceeding ahead. Okay, no doubt. Fine. Priti Mishra, no doubt. No sir. No sir. Okay, fine. So let us switch to the detailed explanation of this. Well, Lakshmi Rani Patra, we have moved so ahead. We have moved already ahead. Do one thing. Message me. Okay, text me your doubt. All right. So you can text me your doubt in WhatsApp or in Facebook. So you text me your doubt, I will be answering over there. Alright, so this is a question related to laws of motion. Now I am about to discuss the factors affecting acceleration due to gravity. Okay, so you text me your query, I will be replying it. You text it in the WhatsApp or in Facebook. Okay, so question number, so factor one or first factor, how does height affects? Let us see. Listen, the value of small g is written as capital G m by r square. Now, g, as we all know, it is universal gravitational constant. M is mass of the earth. R, radius of the earth. Okay, or let me take it as me and me, mass of the earth. Now see, this is my earth. So this is my earth. Now this is the center of the earth and this is the radius of the earth. Now say this is the object located say at a height h from the surface of the earth. Okay. Now what is this r? This r is actually not exactly the radius. Let me write down in this way. Here it is the r. So this r is the distance of the object from from surface from center of the earth to the point where object is located. To the point where object is located. So this is the center of that. This is the point where the object is located. So the distance, you can see, what is the distance? It is from here to here it is r, from here to here it is h. So the complete distance is r plus h. So how can I write small g? Small g can be written as capital G me divided by r plus h whole square. As you can see from this particular equation, g is inversely proportional to r square. That means if my r square will increase, g will decrease. This is r plus h. Okay, now r plus h whole square is greater than r square. So what will happen to this g? Say this is g and this is my g dash. So what will happen? Now this denominator part has increased. So my g dash will decrease. So I can say that g dash will be less than g. So what is happening with increase in height? What is happening to acceleration due to gravity? It decreases. Okay. So yes, small g value decreases. Okay. Small g value decreases with increase in height. Okay, small g value decreases with increase in height. I hope it is clear to you all. The first factor, how it is, how the acceleration due to gravity gets affected due to increase in height. Okay. Yes. Now let us move on to the next, that is the depth. Say this is my earth. This is my depth d. Let me draw a bigger diagram. Okay, this is earth. This is depth d. This is my earth. This is my actual radius. So what will be this radius? This radius will be capital R minus d. Yes. So I can write small g capital Gm by r square. If I expand this, how will be writing this? Small g can be written as capital G into mass is nothing but density of earth into volume of earth divided by r square. So I will be writing small g as capital G into density of earth into 4 by 3 pi r cube. Why 4 by 3 pi r cube? I have assumed earth to be sphere. I have assumed earth to be sphere. Okay, so this is 4 by 3 pi r cube and now divided by r square. So 1 r square and r cube will get cancelled. I will have here r. So this implies g is equal to capital G into rho e into 4 by 3 pi r. So this is my equation 1. Okay, this is my equation 1. Now if I take at a radius of r minus d, how can I write? Let me write this as g dash is equal to capital G into re into 4 by 3 pi into, in place of r I will be writing it as r minus d. Okay, so this is my equation 2. Now if I divide 2 by 1, equation 2 has been divided by 1, so g dash by g is equal to g into density of earth into 4 by 3 pi into r minus d. Listen, the density will not change with increase in depth because I'm simply locating the object at depth. Okay. Also, density is defined as mass per unit volume. Alright, so density will not change. Density of an object always remains constant irrespective of its mass and volume. Okay. So this is 4 by 3 pi into r minus d. Okay, divided by capital G into Re into 4 by 3 pi into r. So G will get cancelled. Density 4 by 3 pi, 4 by 3 pi. So I can write G dash by G as r minus d divided by r. So if I split this term, that is r by r minus d by r. So this is 1 minus d by r. So G dash is equal to G into 1 minus d by r. That means what is happening? If I increase the depth, what will happen? If I increase the depth, this particular d by r ratio will increase. So if d by r ratio will increase, 1 minus d by r ratio, the result of it will be very less. That means G dash will be lesser than G. So with increase in depth, what will happen? Acceleration due to gravity will decrease. Okay. So when depth is increasing, my small g value will decrease. Alright. So I hope this is clear to you all. So with this we come to the end of this session. We will be continuing with the next factors in the upcoming classes. Do go through those videos once again, make your own notes. In case of any query, do ping me in the next class. I hope it is clear to all. Revise these concepts again and again to brush them in your memory. Alright, so with this I wrap up the session. Thank you for joining us.